In this video, we're going to continue our discussion of basic DC circuits. As we said before, there are several types of components that can be added to our DC circuits, such as resistors, capacitors, and inductors. We're going to look at the resistor this time, which, as its name implies, resists the passage of current. The greater the resistance, the more the current in the circuit is reduced. The unit of resistance is the ohm. And the ohm is designated by the capital symbol omega. So 1 ohm is equal to 1 volt per amp. As the circuit diagram shows, the resistance, which is given by this little symbol, is a set of jagged lines. This is a pretty standard symbol that you'll see in most circuit diagrams. The relationship between voltage, current, and resistance, however, is governed by a very important and well-known equation known as Ohm's law. It says that the voltage is given by the current flowing through a resistor. By Ohm's law, the greater the resistance, the smaller the current. This makes sense because the more the resistor resists the flow of current, the fewer electrons the battery is able to actually force through the circuit in a unit time. Related to this are Kirchhoff's laws. And Kirchhoff's laws are two more laws that help govern electric circuits. First Kirchhoff law is known as the junction rule. And it says that if you have a current flowing into a junction, this little junction splits into 3 ways in this example, we're going to get current coming out in each of the 3 directions. And what Kirchhoff's law says is that the current flowing in is equal to the current flowing out. And this actually really makes sense if we think about what current is. Current is nothing more than the number of electrons flowing past a point. So if an electron comes into the circuit, it has to go out. So if we have 400 electrons coming in, 200 coming out, 100 coming out, 100 coming out, we have a net flow through that's constant. 400 here, 400 there. What comes in, what comes out. And really it's just saying that charge is neither created nor destroyed. So again, mathematically, we can say this: the total current is equal to the sum of all the currents flowing in and out of the system. The second of the Kirchhoff's laws is known as the loop rule. And it says that if you go around a loop like this, that the sum of all of the voltages that we come across, all of our batteries, and the sum of all of our voltage drops over resistances has to add to 0. Again, this slide says the sum of all the voltages, all the voltage sources, and all the voltage drops add to 0. And this is over any loop in a circuit. And this is nothing more than a statement of conservation of energy. If we start and end at the same point in the circuit, we should have the same energy.